Okay. Well, so I'm Carlos. I'm a software engineer at Google, and I'm going to talk about the DAOS on Google Cloud. Right. So what we'll present today is first a quick intro to Google Cloud, essentially why some of our customers choose to do HPC on Google, the various types of storage that we offer, and how does that relate to DAOS. So we're going to focus very quickly on the ones that we use to build a DAOS system on Google Cloud. Then quickly show what HPC architecture looks in Google Cloud and what is the typical data path, meaning that how customers bring their data from on-premises to Google and then back. Then we're going to focus on specifically what we provide for DAOS on Google Cloud. At that point, I will hand over to Johann, and he will go through the performance numbers. So let's start. We have quite a few customers that do HPC on Google. There are a variety of reasons for that. I think some of these are the fact that we provide fairly good VMs, of course. The compute, our VMs boot in seconds. It's very easy to auto-scale for computation, and they provide some consistent high performance with good security. In terms of networking, we provide high throughput, low latency interconnects, relatively low latency interconnects, but they achieve very high aggregated throughput that allows customers to scale to very large jobs. And we provide various storage offerings. So basically that a lot of those are fully managed, and it removes the burden of building and manage the entire storage, I would say. Specifically, also, we provide a lot of different HPC software that uses this whole our infrastructure, and that comes in form of either partner offerings or open source projects that we have using that. For the storage types, right, we have a lot of managed and unmanaged offerings, but essentially we have in-memory databases, relational, NoSQL, analytical, etc. I think in terms of HPC, a lot of times the customers will use object store as kind of a landing zone or staging area, block storage for the computation itself. So basically they appear as a persistent disk or local SSDs, and or file offerings like file store as a fully managed NFS offering, or partner offers that are built on that. For the case of DAOS, right, we are going to use the local SSDs, which are exposed as NVMe devices, and provide up to 9 GB per second per server instance, per server node. So what does, how does an HPC environment look like in the cloud? Well, it's not all that different from on-premises, I think, in terms of build, in terms of major building blocks, right? You're going to have a scheduler host in general, number of licensed servers, maybe remote workstations. A key difference is that that scheduler host oftentimes will auto-scale. So we will have as many compute nodes as you need for process your current jobs, and then that will then go to zero if you're not having any job, right? So basically that the bulk of your compute infrastructure will be those computing clusters, and they may be spot VMs or on-demand VMs, and they typically auto-scale. But most of the time, those compute nodes access some sort of storage, depending on their needs. And those, like I say, it will be either NFS storage or parallel file systems, which in turn communicate to object store, and so on. In terms of data movement, though, the story is a little bit different, right? What will happen typically is that our customers, the data or the seed of the data, which I like to call, originates from the storage on premises, and they will move that most often to the object store. and then move that intern to their storage on the cloud, whatever that is, either NFS or a parallel file system. That allows them to do the native data analytics jobs, BigQuery, the AI platforms, the processing, data flow, etc., directly from Object Store, and then in turn have their compute nodes processed from their file system. Less common, but also exists, is where the customers send their data directly, either SCP or something, directly into their storage. That happens more often. That typically happens when you have less, smaller data sets, right? For large data sets, this is not very common. Also, thank you, Chen. What happens sometimes is that some applications directly access GCS, and of course that requires applications to be changed, but customers see the scalability benefit from doing that. Right, so now let's focus on DAOS, which would be one of the offerings here. What we provide on GitHub today is a set of recipes to build DAOS systems on Google Cloud, right? What we are targeting at this point is more of kind of a scratch file system for those jobs, right? So it's relatively ephemeral. And we provide 2 Terraform modules that you can build with, right? A DAOS server and a DAOS client, both of which use managed instance groups, which are an easy way to scale nodes of a given type. Based on those modules, we provide a few examples that are either a simple DAOS server that is just a managed instance group that runs DAOS, a number of DAOS server nodes and behaves as a single DAOS instance. You can have, of course, build a client as well and a full cluster set up at both clients and servers. And of course, we automate that to run IO 500, which we expose as well as a fully automated deployment that runs IO 500. So I think let me hand over to Johann now and
thanks a lot, Carlos.
Talk about the comparison.
So in terms of configuration, so we have those Terraform scripts that generate the image, populate automatically the YAML file for the server, set up with systemd the service on the server side, or the DAOS server and the engine. And in terms of configuration, we have tested a few combinations. And what we do today to provide the maximum performance or an optimal cost, also there are always improvements we can do, is to use 1 target per SSD partition. DAOS, usually we don't use hyperthread, so usually we use 2 vCPU, 2 hyperthread per target, and effectively we use only 1. There are definitely some improvement that we can do in the future to be able to leverage hyperthread both in the cloud as well as on-premise. Since there is no PMM, as you will see in the next slide, we are using DRAM to emulate storage class memory, and you need to obviously to adjust the amount of DRAM that you need depending on the capacity of SSD that you have, right? You know, you have these rules about between 1% and 6%, depending on your use case, and here you can adjust. What is very great in this environment is that if you need more memory, you just get more memory, right? You are not as much as constrained as you might be on-premise for different use cases. We did some analyses, and basically today we use N2 IMM16 with 1.5 terabyte SSD per server to provide the burst performance, and N2, which are Intel Cascade Lake, I think IMM32 with 6 terabyte of SSD per server for the best cost per gigabyte, so the most capacity optimized. When you deploy everything with Terraform, at the end, you end up with a fully configured DAOS system that has all the interfaces listed here available. So obviously you have libDAOS that is installed. We have the DAOS client RPM installed that comes with the native DAOS API, also the libDFS that implement the POSIX semantic on top of libDAOS. Diffuse is part of the same RPM is installed. The interception library as well is available. Since we install MPI, Intel MPI, we have also merged the MPI driver into Intel MPI. Maybe not last version, but it has been a few years already that it is included there. So you can also use MPI natively, just because as part of the image we install Intel MPI. And DAOS also come with a Python module that is called PyDAOS that support key value store, but also a more raw API, very close to the baseline API. It is also installed. There are other middleware that have been presented at this conference, but like the Jafu's presentation on the HDFS Java binding, they are currently built externally to our build system that are a jar Java file. And typically we don't install it inside the image, but that's definitely something that should be easily doable, provided that we have the people who know we have the right skills to do it. And we have. Could you please move on to the next slide, Carlos? So in terms of limitation, as I mentioned before, we deploy DAOS over DRAM. So all the metadata are stored in DRAM. The data are stored on SSD. So obviously, if you do a full shutdown of all your instances and restart, then the data that is on SSD is still there. But obviously, all the metadata that were in DRAM emulating SCM will be gone, right? So this cannot survive a full reboot of all the instances, but you can enable data protection, right? And as long as you don't lose more instance VM than the level of data protection that you have, then your data will always remain accessible, right? And durable. So the use case that we have been looking into that Carlos presented before will fit into this usage model. There is another limitation. You can get today up to 9 terabytes of SSD per node in GCP, and currently we are limited to 6 terabytes due to some limitation we have with the ASPDK and DAOS in this environment. But we are working on it and we'll be addressing this limitation. Please move on to the next slide, Carlos. So now in terms of performance, as Carlos presented, we have a full automation of IO 500. So that's very friendly. We are able to run it very quickly, spawn new instance, format DAOS, create a pool, mount the container on the client instance, where start the agent first, then mount the container and kick off IO 500 with Intel MPI. All of this is automated and we can get result pretty quickly. So that's pretty nice. Not something we are used to on premise, definitely. And so we have a lot of performance data. If you want to know more, we're happy to have more private discussion about those results. We just picked up one configuration that we have here with 10 N2 IMM 16 clients. So those are the compute node. There is no real restriction on the compute, right? Obviously, they are different. You are very sensitive to the network bandwidth. So the more vCPU you have, potentially the more bandwidth. So that's what might help DAOS. But really what is important is more on the server side. So we are using here N2 custom with 20 vCPU and 128 gigabyte of memory. And in specific configuration, we're using 3 terabyte of NVMe SSD. So in gray here, you have the theoretical max write and read bandwidth that are published inside the spec of GCP online. And in dark blue, you have the performance we got with DAOS. By DAOS with IOR-EZ, and the light blue is IOR. So this is right at the bottom and read at the top, right, the dark blue. So we are above the specs basically. We are using the TCP provider here. We have no offload at the leaf fabric level, and sounds like the Ethernet network is pretty efficient, and we are able to saturate the SSD, get even more than what is on the spec. Please move on to the next slide. So in terms of IOR hard, we are a bit more sensitive to small messages with the TCP provider, but that was with the old Leaf Fabric version. There have been a lot of fixes done in Leaf Fabric to improve the TCP provider performance, and we haven't retested yet. All those testing was done with DAOS 1.2, and we will be obviously retesting when 2.0 is GA with the newly fabric version that are a lot of fixes and improvement. But here, performance with hard were more than reasonable. I think we can still get better, but I think they were pretty good comparing to the easy performance. That was again with the same configuration. Let's move on to the next slide, please, to MD test. So now we have MD test easy and then MD test hard. So in terms of creation rate, we're able to reach with those 8 instances 600 K IOPS for empty file creation. Stats should have been slightly better. Usually we have stats slightly above create. There might be some optimization here we can do, and there is no reason why it should be lower, but we need to investigate more, and I'm convinced we can get it slightly above the create IOPS like we are used to. And destroy, delete is a more heavyweight operation, because even if the file is empty, we need to truncate the file everywhere. So there is more RPC over the network that explain the drop, but that's typical ratio that we have even with other IO500 run on Wolf or Endeavor. Moving on to MD test hard. So obviously with MD test hard, we don't create empty file. We're actually writing to the file 3.7K. So this is why the create performance slightly drops. You are doing more operation, right? There is no magic, but so we were able to go above 200 or around 200K IOPS for create. Delete was roughly consistent with what we had before, and stat performance here was compared to what we have with Easy. And again, there are several improvements we can make here in Mercury and into the TCP provider that we will retest with 2.0, but the results are very encouraging and very good. We go to the conclusion. Yep.
All right. So in short, well, okay. So to recap, we provide a simple and fast way to deploy DAOS with very good performance. We keep in mind that we deploy, the system is ready within about less than 5 minutes, right? I mean, it's 2 to 4 minutes. So it's a very quick way to create a file system that is powerful. In the future, we want to automate data movement to and from GCS, right? Today, you can do it, but it's not as automatic. We want to get a tiering very like a first-class support. We want to add telemetry, potentially integrating with our cloud monitoring offering. We want, of course, to add further automation options to create partitions, mounting clients, etc., etc. For also, today we have full automation for IO500, but we would like to have automation for other use cases. Of course, increasing the storage to 9 terabytes per server node. And then maybe better guided initial configurations where you have a potentially one example for best IOPS, one example for best bandwidth, and then lower cost per gigabyte. Let's see questions now.